recall that the limit definition of a derivative is that f prime of x equals the limit as h goes to 0 of f of x plus h minus f of x all over h, and the definition of the derivative at a point is the limit as x goes to a of f of x minus f of a over x minus a. So these are two limit definitions of the derivative that we need to know. But it can be shown that a lot of derivatives, you wouldn't want to have to use the limit definition every single time. We'd like there to be faster ways that ultimately have been proved because of the limit definition. And we're going to start with something like this. If we have a function, and that function is defined by x to the n power, to find the derivative of something to the n power, the derivative of x is found by dropping the power down. So I've brought the power down, brought it out front, and that's multiplied by x to the n minus 1. So I'm dropping the power and decreasing the exponent by 1. And the proof of this is in your textbook if you want to see the proof. It's on page 131. But there is a proof for it if you're interested. But we'd like to move on and actually apply this power rule because calculus really cleans up a lot. So, some examples. If we have y equals x to the 7th and we want to know its derivative, instead of using the limit definition, we can use the power rule. The derivative would be 7 because I'm bringing it down times x to the 6th. This is an expression for the slope of the tangent line at any value x. So if I want to know what's the slope of the tangent line to x to the x to the 7th at x equals 1, I will take the derivative of x to the 7th, substitute in 1, and I would find that the slope at the x value of 1 is equal to 7. Right? And so now a whole field of things is open to us. Right? We could have y equals x to the square root of 2. What's its derivative? Well, y prime, the derivative of y, is equal to, I'm going to drop the exponent, the square root of 2, times x to the square root of 2 minus 1. Drop the exponent, subtract 1. That's always the derivative of x to some power. Second thing I want to emphasize here is if you have a constant, like y equals 5. Now, it should be obvious why this is the case, but we'll mention it. If you were to graph y equals 5, that is a horizontal line at 5, and the slope of all horizontal lines is 0. Since the relationship between a function and its derivative is the slope of the tangent line, y prime in this case is 0. And more generally, if y equals some constant, then the value of the derivative is always 0, because the function y equal to a constant is a horizontal line, and the derivative, or the slope of all horizontal lines, is 0. So there's the power rule and the derivative of a constant.